know I'm working with a flat surface. Some of their drawings won't work out, and there's two issues. Usually you get the inside surface, and the second big issue is you don't cut a flat plane. Your plane's actually got a curvature to it. And that's a whole different ballgame. We can deal with that, but it's a very much more complicated thing. So because I have two triangles, I know they're both flat. So this is kind of where you should start. Everybody should have this information by right now, right? So now is when we start the thing that's new to you, the descriptive geometry. So what's step one? Step one, write this down, right? If you follow these rules in this order, it will work every time. Step one is to create an auxiliary construction line that locates an auxiliary point, right? That's the first thing we have to do. We construct that line by offsetting a line parallel to one of the folding lines, right? So, it doesn't matter which direction we go. This is my line. I need to go parallel offset through a known point. Which direction do you want me to do it? Somebody tell me. Up or down? Are we working on the vertical or horizontal? Horizontal. So you want me to go up here, just like this example?
Yes.
Okay, so we're going to offset this parallel, and we're going to go through a known point. The only known point that makes sense for me to go through is through C. Right? If I go through A, I don't intersect anything. If I go through B, I don't intersect anything. So I'm going to go through C, and that's as parallel as I can draw from here. Right? And that's going to give me a new reference point. And this auxiliary reference point is right there, and we're going to call it X sub H.
How do you define the word auxiliary? What does it mean?
Additional, yeah. Additional point. It's one that it wasn't part of the original definition set, right? Now, all of our projection lines are always perpendicular to the folding lines. So these are always 90 degrees, right? So that means this auxiliary reference line is also 90 degrees, and we're going to draw through here. I usually do these in dashed lines, right? And this line I'm going to do a little sub X on, right? What we see right here are there are two intersects, just to show. We have two potential locations for that X to be on, right? So we need to look at what line it really belongs on. It belongs on line AB. So it belongs on line AB here as well. And that means it's right there. This is X sub B, right? And what did we do with it up here? How did we get it? We offset this line parallel, right? So this line right here could be described as a small line because it's a construction line or a projection line. This could be described as XC, line XC, right? We need to get that on this point right here as well. I'll use this to try and draw, I'll use a ruler, to try and draw it as straight as I can. And it just essentially goes to infinity. So this is XC in the vertical, right?
So is that
That's this same line just projected onto the surface.
so 90 degrees to the
No,
parallel?
it's through point A and point C.
Oh.
It is not
X.
parallel or perpendicular to that. It's the thing we get the next line to be perpendicular to. Right? Now what we use this for is we use this to create our first auxiliary folding line. And this line is going to be at a 90 degrees. So we're going to put it, I'll come out here so it's not too buggered with the other one. Actually, I don't want to go that far because it'll be too deep. I'll run out of board. I'll put it closer. Here. We got to label this again. This is V on this side, right? And this is the first auxiliary one, which will be A1.
What is that perpendicular to?
This is perpendicular to this line AC,
Okay.
or excuse me, XC, right? Perpendicular to that line.
Does that have to be before the VP?
No, it doesn't, it makes no difference where that is at all. That could be here, it could be there, it could be here. The only thing that does is tell you where the two planes intersect. And the other thing it does is it will be how far back you have to measure the depth. Right? So if you do it really far away, you'll have a lot bigger depth to measure. So you don't want to go too crazy. But it can actually be, I'll tell you this. What's that? Yeah, it could actually be right here. It could be over here. It's kind of confusing. The important thing to know is what side is vertical and what side is auxiliary. As long as you keep this the vertical side, you could put this right there, you could put it right here, you could put it over there. It doesn't matter as long, the only rule is that it's perpendicular to this line AX. Right? So you can do these drawings right on top of each other.
Can you please just write so we can see what you just explained?
Yep. So everybody see how we got to this point?
Yeah.
Yep, okay. So this line right here, all it is imagine where the paper's folded, right? It doesn't matter if we fold the paper here, or if we fold the paper there, or if we fold the paper there. We're still looking at the same two views, right? And even though it's physically not possible, theoretically, it's possible to fold the paper here. As long as we look at this side of it, it doesn't matter where it is. As long as you're always looking on that side, we can actually fold it on the other side of the object, because it's about where the reference point is. Right? But it'll be easier if you kind of imagine it as a box folded. So keep it this side. All right? So now what's the next step? Who can tell me from this drawing? Now we've got to try and find, we found this one, right? Now we've got to try and get this line here, this triangle surface into a single line.